Huawei, a global leader in telecommunications and electronics, is reportedly making significant strides in semiconductor technology by developing 3nm chips. This effort is particularly noteworthy given the company's constraints due to U.S. export restrictions, which have prevented it from accessing the latest extreme ultraviolet lithography equipment. Instead, Huawei and its manufacturing partner, Semiconductor Manufacturing International Corporation, are leveraging deep ultraviolet DUV lithography to achieve this technological milestone. This essay delves into the implications, challenges, and strategic maneuvers surrounding Huawei's ambitious project. Huawei's journey in chip development has been fraught with challenges, primarily stemming from geopolitical tensions and trade restrictions imposed by the U.S. These sanctions have barred Huawei from using advanced EUV lithography, which is crucial for manufacturing the latest generation of semiconductors. Despite these setbacks, Huawei remains undeterred, focusing its efforts on utilizing DUV equipment to produce 3nm chips. SMIC, China's leading semiconductor manufacturer, plays a critical role in this endeavor. The company has reportedly set up an internal R&D team dedicated to advancing its 3nm process technology using DUV lithography. This partnership aims to reduce Huawei's reliance on foreign technology and enhance China's self-sufficiency in the semiconductor industry. Technical and strategic challenges. The use of DUV equipment for manufacturing 3nm chips presents several significant challenges. DUV lithography, while effective for earlier nodes such as 7nm and 5nm, is less precise than EUV, leading to lower yields and higher production costs. EUV lithography, developed by ASML, is the industry standard for producing the most advanced semiconductor nodes due to its ability to print finer details on silicon wafers. Huawei has been testing a quadruple brute force technology for making 5nm chipsets. Some reports even pointed out that SMIC has laid the line for advanced processors production, and results might become visible by the end of this year. Huawei had issued a new patent entitled Method for Manufacturing Self-Aligned Quadruple Patterned Semiconductor Apparatus and Semiconductor Apparatus. Self-aligned quadruple pattern technology plays a significant role in making advanced chips. It's a good alternative to the equipment that the Chinese phone makers can't access due to U.S. restrictions on cutting-edge chip-making tools. Self-aligned quadruple pattern technology refers to engraving lines on silicon wafers, again and again, to raise the density of the transistor and lessen the power consumption, thus enhancing performance. Both the Kirin owner and the SMIC firm allegedly looking for 3nm process development via SAQP and DUV equipment. But some hurdles still exist in this consideration. While many tech experts predicted that the respective technology may let Chinese OEMs develop only a 5nm process, Huawei could use it in the making of 3nm, yet self-aligned quadruple pattern technology could be a one and only solution for SMIC and Huawei at the time being. It may help to boost the production of both Kirin and AI-based Ascend processors. Hence, let's take this news as a grain of salt for now. SMIC's attempt to produce 3nm chips with DUV technology is seen as a complex and resource-intensive process. Reports suggest that this method could result in production costs up to 50% higher than those incurred by leading manufacturers like TSMC and Samsung, who use EUV technology. Furthermore, achieving competitive yields will be a formidable challenge, potentially impacting the commercial viability of these chips. Government support and strategic investments. To mitigate these challenges, Huawei and SMIC are expected to receive substantial subsidies from the Chinese government. This financial support is crucial for offsetting the high costs associated with DUV-based 3nm chip production. Additionally, Huawei is investing heavily in its semiconductor R&D capabilities. The company is constructing a $1.66 billion R&D facility in Shanghai and has recruited experienced engineers from top global semiconductor firms such as ASML, Intel, and TSMC. These strategic investments reflect Huawei's long-term vision of achieving technological self-reliance. By developing its own semiconductor capabilities, Huawei aims to reduce its vulnerability to external pressures and continue innovating in the highly competitive tech industry. Implications for the global semiconductor industry. Huawei's efforts to develop 3nm chips using DUV technology could have far-reaching implications for the global semiconductor landscape. If successful, this initiative would mark a significant advancement for China's semiconductor capabilities, potentially reducing the country's dependence on Western technology. However, the competitive landscape remains challenging. Industry leaders like TSMC and Samsung are already progressing towards 2nm and smaller nodes, leveraging their advanced EUV capabilities. Huawei and SMIC will need to demonstrate not only the technical feasibility of their approach, but also its commercial competitiveness to gain a foothold in this rapidly evolving market. Huawei's rumored development of 3nm chips using DUV equipment underscores the company's resilience and strategic ingenuity in the face of significant geopolitical and technological challenges. While the path ahead is fraught with technical hurdles and high costs, the potential success of this initiative could redefine the competitive dynamics of the global semiconductor industry. With substantial government support and strategic investments in R&D, Huawei is positioning itself to overcome these challenges and contribute to China's broader ambitions of technological self-sufficiency. The coming years will be critical in determining the viability and impact of Huawei's bold venture into advanced semiconductor manufacturing.